Excellent. Thank you very much, everybody, for coming along. I'm going to talk about subdomain hijacking. A little bit interesting because it leads on quite nicely from the following talk and one this morning about initial access and how the attackers can create credible phishing links. So I'll get rid of the who am I first. So my name's Daniel Oates-Lee. I'm one of the co-directors of Punk Security. I'm a DevSecOps enthusiast. I started off as a developer, then moved into operations, and they quickly found out I was pretty good at breaking stuff, so they put me in security. I love automating stuff, and I'm just an out-and-out geek. I like writing open source tools. I like attending conferences and doing CTF stuff, so whilst I'm a director, I'm also extremely technical. Punk Security is a DevSecOps consultancy, but I'm going to be talking about DNS Reaper later on. But we have also got 3 other open source tools if anybody's interested. We've got a secret scanning tool, a file SMBeagle, which is a SMB auditing tool, and PwnSpoof, which generates threat hunting logs for you to go and have a look at. And last month we ran a DevSecOps CTF. Anyway, what am I going to talk about today? I'm going to cover off how DNS works very quickly. Then we're going to talk about 3 different subdomain attacks. Then why should we care about this? And then how can you defend yourself? So, a quick introduction into how DNS works. Basically, DNS has 13 root servers. Most of them are stored in the US. And these hold the TLD NS records. So these are like the .co.uk's, .coms, .ios, whatever the TLDR DNS name is. Then from there you filter down to those name servers where you would generally go and buy your domain that you're interested in. So in our demos today, everything's going to be Punk Security because obviously I own that and I can abuse it. And that's where you'll go and buy your DNS names. Underneath there, you will then have a DNS zone where you'll store your DNS records. Now, this will either be hosted with something like GoDaddy or Azure or AWS Route 53, and you'll normally. And this is where you'll hold things like your A-class records, your AAAs, your CNAMEs, your NSs, pointing off to whatever web service you want. So, just quickly recap: the root server we have no access to. We can't configure that. We can't do anything. The TLDRs, that's where we register ourselves, and we then configure the bottom bit down at the bottom. So how does that look when you're connecting to the website? Well, obviously, if we wanted to connect through to our website, we go to BT, if you're using BT, and it will go off. It will then go through and say, where's .co.uk to the root servers. It will then say, this is where .co.uk lives. You'll query who is Punk Security to the co.uk, and it'll return back an IP address to go through to Azure to our DNS zones to go and pull back www, and then BT will return to you an IP address. So what are subdomains? Well, we've just quickly covered off the very first part of the DNS the name DNS names. So the root domain would be punksecurity.co.uk. The bits that you can see in green, these are the subdomains or the hosts. And these are the bits that can be abused potentially. So in our case, we're going to look at docs.punksecurity.co.uk today for our first takeover attack. So as we're moving into this brave world of DevOps and cloud, we tend to like using more and more cloud services for hosting stuff. But this can lead to misconfigurations or errors or services being disconnected. And how many people in this room can hold their hands up and say, I have complete control of my external DNS zone. I know exactly every single record that's in there and where it's pointing to. And if I take down an external service, I will get rid of that record. No one? Okay, that's good. most of the rooms can't. So we're going to have a quick look at this. So what is a subdomain takeover? So in this case, our development team have asked the support team to create a CNAME record for docs.punksecurity.co.uk to point it off at GitHub. So what GitHub will do is it will basically, when you go to docs.punksecurity.co.uk, it will redirect you through to punksecurity-docs.github.io. Now, I'm going to do a live demo, hopefully, if all works well. And we're going to have a quick look at what that looks like inside DNS. So if we do a quick NS lookup on the CNAME docs.punksecurity.io, we can see here that it's pointing off to docs-punksecurity.github.io. If we go and have a look at that website, docs.punksecurity.co.uk, we can see that there isn't actually anything there at the moment. Now, this would indicate to an attacker that that is not available, like we haven't finished off the final part of the configuration. Unfortunately, GitHub is rather poor at validating that you own the domain that you say you own. So if we go to, I'm currently logged in here as a different user. This has got nothing to do with Punk Security at all. It just happens to be an account that I've created as docs.punksecurity.co.uk. It's owned by somebody called General Failure. So if I go to the repository and I go to my repository, I can now add that domain to this repository to this repo to be able to host a malicious website posing as Punk Security. So if I go down here, go to Pages, and underneath the custom domain, just type in docs.punksecurity.io. I think it was. If I save that, it will be checking the DNS to make sure it gets redirected through to this address here. It's just checking. So that's the address there that it's planning. There you go. It says it's been successful. If we go back and visit that page, I'll just clear that and reopen it. Okay. Ah, come on. It's the curse of the demo gods. It worked just over there. Come on. Refresh. No. Okay. Oh dear, we've just landed a page that looks like it could be used for capturing somebody's on Microsoft 365 account. So from something as simple as our support teams creating a DNS record and pointing it to an empty space up in GitHub, an attacker's been able to find that DNS takeover and go and launch a page. Now, we've done this, we've scanned for DNS takeover attacks in the past, and we've found pages that we were able to take over for PlayStation and multiple other companies. I think there was a couple of members in the audience who were telling me earlier that they've used DNS Reaper and have found other DNS takeovers as well. So this is a real attack that is beginning to become more prevalent because we're using more cloud services rather than running our own web services. So the second type of takeover attack that I'm going to talk about is a name server. So we've obviously got the main DNS zone, which is punksecurity.co.uk, where we host our hosts. But what about if the development teams want to be able to control their own DNS records? We might want to delegate to them their own DNS zone. So in this case, we want to give them dev.punksecurity.co.uk because they might want to be able to control their own web services for testing and being able to stand up their own internet-based services. So how that works is underneath our punksecurity.co.uk here, we underneath the NS records, we can point it to another zone where they can then host their own records. So in this case, what we're going to look at is we're going to be looking at Route 53. And what we've done inside here is we've created a punksecurity.co.uk DNS zone. And if this is playing correctly, which it is, brilliant. So what we're going to do inside here is we're going to go and create dev.punksecurity.co.uk, like a good administrator would do on the basis of a ticket. He's then giving it a name, a description of developer, which is great. So he's now stood up that DNS zone in Route 53. Now, in the punksecurity.co.uk main DNS zone, we need to go and add name server records. So then when people go to punksecurity.co.uk and they want to get to the dev resources, they know which zone to get to. So we go inside here, we create a new NS record, and can anybody spot the mistake that the poor administrator's just made? He's just created developers.punksecurity.co.uk. Now you might think, well, that might not happen. It does happen quite regularly. So what happened there? What happened there is rather than creating he created the zone dev.punksecurity.co.uk so the developers could go and create their own name records. But then in the main Punk Security, he created an incorrect NS record, which left developers.punksecurity.co.uk unassociated, basically. Now, how can we exploit this? Well, luckily in AWS world, you go and create your DNS zone, and it will randomly pick different name servers to go on. So the first time you might register, the target is what we're trying to get to. We're trying to get onto those servers there. The first set of targets, though, unfortunately, we didn't get any. The second time we run it, it might get 2 of them. And the third time we run it, we might get a bit more. We're quite happy because we've now got the first and the second. So most requests are going to hit those 2. Now, that's actually pretty trivial. We wrote a little Python script to register the zone, then check the NS records where the zone's being held. If it's not being held on the right servers, delete the resource and try again. And you'd be surprised that you can probably run about 1,000 registrations in less than about 2 or 3 minutes. And you can probably hit the right name servers pretty quickly. So now if an attacker can own a name server that's underneath your domain, they can start creating credible phishing lists. So what is the so what? Well, obviously they can start creating credible phishing lists. I mean, Uber had this against them, a name server takeover. And the attacker took over signup.uber.com, and then were able to send out phishing links using that to trick people to go and hand over their usernames and the passwords, or to click on a link and download malicious things. We can also start creating email MX records as well, so we can start hosting our own mail servers as one of the subdomains of the main domain service. And lastly, we can also start looking at loosely scoped cookies. So this is like the third attack. So what a loosely scoped cookie basically is the ability of being able to use a cookie from one of the parent pages in any of the subdomains. So if we look here, if we created a cookie on our main web page, www.punksecurity.co.uk, the attacker would be able, if they took over one of the name servers or took over one of the CNAMEs, like on GitHub, they would be able to get a feed of the cookie from the main website. So how does that look, and why does that happen? So if we see here, we have actually got a couple of cookies there already. So we've got ones mainly for Calendly. So if you look at Calendly there, If the cookie doesn't start with a dot, it means that it can be applied to any subdomain or any website underneath. So here goes for another demo. Let's see if I can try and get this one right. So here we're going to use we didn't really want to stand up a proper website, so we just created a local one called example.com. So what we're going to do here is we're going to open up a developer's page. There is no cookies in here at the moment. So what we're going to do is going to create a very quick cookie called authentication cookie, which, may well exist in other apps. And we're going to give it a secret value. And what we're going to do here is we're going to be it's really important that we're going to make sure that this is a loosely scoped cookie. Because what we'd like to show you is what would happen if an attacker stood up a website after taking over that name server and were able to stand up their own web service. So, for instance, if, like in the Uber case, they might go to uber.co.uk, the user might log in and be already authenticated. And then when they click on the sign up phishing link, it'll open up inside their browser and their authentication cookie will be passed down to you. So in this case, we're going to go to subdomain.example.org, and there you go. You can see that we've just taken the cookie, and we've also got the secret there as well. And that is basically the third example of why you don't want to have these subdomain takeovers. So how can we defend ourselves? Well, we can carry out periodic reviews. We can do DNS hygiene. We've got 1,000,001 other things to be doing that we're probably not doing as well as we could be. So DNS hygienes are typically not going to be very productive. You could sign up to a bug bounty program, but they tend to charge you quite a lot for finding a subdomain takeover. You could extend your pen tests and ask your pen testers to check your DNS records for subdomain takeovers. But, you're probably already running out of time with most of your pen tests anyway. And putting more requirements on top of the pen test is going to probably dilute it. Or you could use IAC, or does anybody use infrastructure as code for controlling their DNS records at the moment? Maybe 2 or 3 people. I do it all the time. I find it much easier because then I can put it under Git control. Or you can use our free open source tool called DNS Reaper. So DNS Reaper, it's a little Python script, but we've also built it as a Docker container, so you can run it as a Docker service. You give it access to the domain that you want to have checked, so it can either log into Azure or AWS or Route 53 or Bind server, or you can feed it a flat file with the domains that you want to have it check. It will then go through and it'll check all of those domains and all of the A class, the C names, the NS records, and use some signatures. So rather than telling you, we think it might be susceptible, we've gone off and we've written 60 signatures which actually check that the site then means that it is more susceptible. And then we give you the results either on the screen in a nice CSV file or a JSON file. So the use cases are, you can use this for checking your own infrastructure. So go home, check your own public DNS zones, make sure that you're not susceptible. You can also sign up to bug bounty programs and go and make yourself some dollars yourselves. And a few people have done that already. And you can also use it for preventing bad deployments. So if you're doing infrastructure as code deployments and controlling your DNS in IAC, you could maybe run DNS Reaper afterwards just to make sure that what you've created hasn't been susceptible. So I'm going to just quickly show you here where you can go get it. So you can go get it from our GitHub. It's MIT licensing, so knock yourselves out. We do a lot of security scanning on these and do nightly builds against all of our stuff because we are a DevSecOps company, so we will do those kind of things. Feel free to go and check out the actions. We have documented it extensively. So like for accessing Route 53, we don't want you to go and create an account that's going to give you access to everything within inside your Route 53. So what we've done is, on this particular instance, is we've told you a really nice little IAM policy there of exactly what permissions DNS repo would need for your Route 53 access. And as I say, it's really nicely documented, and as all really good hacking tools, we've got the best ASCII art as well. If you run it in the Docker service, it'll tell you that you haven't passed through some parameters, and it'll tell you what parameters you can use. You can see here that we cover Cloudflare, AWS. You can either scan a single domain, you can from a flat file log it into Azure, DigitalOcean, or Bind. And when you see the results, it will spit them out as you can see them here on the screen. So you can see here that we've given this a confidence of potential, but then you can see underneath that there is a second finding, which is confidence of confirmed. And that's because we've gone and it's checked it using that signature to make sure that it is actually susceptible for a DNS takeover. And I think I'm just a little bit ahead of time, but I can either do a live demo of DNS Reaper, or if anybody's got any questions, I can take some questions.
Did you
Yep.
see a talk at the Envoys conference last year on DNS takeover?
Did I see it?
Yeah.
No, I didn't know.
It's very similar.
Is it? Oh, well, that's nice. Yeah. Did they write a tool, though, to fix it?
Yeah, you did, yeah.
No, they did. Oh, right. No, so this came off the back of us working. So all of our tools tend to come off the back of something that we've been helping a client with. And this happened to be an insurance company that was paying out $200 for every single domain subdomain takeover attack finding in a bug bounty program that they'd signed up to. And so we said, well, that just seems ridiculous. Let us help you reduce that down to 0. And we had a look at what they were doing and wrote a simple Python script with some signatures. So it's good to see that somebody else had thought the same thing, but no, we hadn't seen that. No other questions? All right, well, thank you very much.